So it's my pleasure to introduce one of our own, Jarek Nabrzyski, who is a co-PI of CI Compass, as well as the director of the Center for Research Computing at the University of Notre Dame. And today he's going to be speaking to us about maximizing cloud value for science. So without further ado, Jarek, go ahead and take it away.
Thank you, Nikki. Hi, everyone. Good afternoon, I think, for most of us. So yeah, it's a pleasure to talk about this topic. As you know, within the CI Compass, we run a cloud working group, and we're also thinking how to kind of help you with thinking about the cloud. And this is maybe a kind of introduction to the future, of topics that are also important, and maybe we haven't covered them a lot. But of course, it would be very hard not to repeat myself or repeat what we already said in different reports that we worked on with you all. So bear with me, please. But this talk. Thank you, Nikki, for introduction. I am really focusing or kind of proposing based on my own experience as a director of the Research Computing Center. Of course, our domain is really not a major facility providing, services and data to larger communities, but still, we operate, mid-size data center supporting 2,200 users on campus, and I will talk about it a little bit more. First of all, I want to remind everyone that here we are CI Compass, and here's our team. We represent 6 different universities: USC, RANSI, Notre Dame, Indiana University, University of Utah, and Texas Tech University. And our major role is to work with major facilities, NSF major facilities, and help them with their cyber infrastructure needs. So really, if you look at our mission, we provide expertise and active support to cyber infrastructure practitioners at NSF major facilities and mid-scale facilities, actually. And we really look mostly at the entire data lifecycle, from either sensors or whatever sources of data to basically data sharing and long-term preservation, and then analysis as well if needed. And you can find us easily. Our website is cicompass.org. And contact Eva or Nikki if you like to engage with us. But we work with major facilities through engagements, and right now we have a number of engagements that we run. So today, I'd like to. I don't think I will use all my time. I'd like this to be kind of discussion driven at the end, but I think I'll talk about mostly, why cloud strategy. And so I will talk about a little bit why we need to have a cloud strategy. And I run on-premise facility with systems and data and so on, and still I'm thinking about what is my center's cloud strategy. So I will talk about this a little bit, and I will give you my own example, or our data centers and research centers example. Then we're going to talk about major cloud providers, and especially we're going to focus on their AI and HPC capabilities and services that they provide. Of course, I will mention our, just on the next slide, our cloud adoption projects and survey and reports. And the survey is going on, so there is not maybe much to talk about, but there is also a cloud report that is available to you all, and I will show a slide where to find it. But this actually use cases report shows many interesting use cases that were presented with many of you how you already use the cloud. But some of you may haven't seen this report. I encourage you to download and look at it. And then, I will talk about on-premise versus cloud and strategies. We're going to talk about also NSF funded cloud resources, and also on-prem cloud solutions that I don't think we covered a lot in the reports and our conversations. like Outpost Azure Stack and dedicated region from Oracle. And then a bit about negotiating with cloud providers, although it is also covered pretty nicely in the report. And I already said, actually, we're going to talk about NSF. Okay, so let's try to do it. So next slide is about our cloud use cases, and again, you can find it at this another record. I think very interesting document that describing very powerful actual use cases of how major facilities already used cloud, including IceCube, which is, I'm very impressed with IceCube's kind of 51,000 GPUs running across different cloud providers. So I would really encourage you all to go to this report. Okay, so about myself and about our data center and Center for Research Computing. So as Nikki said, I'm leading the Notre Dame Center for Research Computing. We run around 50,000 cores infrastructure in various configurations, around 400 GPU cards, but mostly, smaller cards. And we started buying this H100, 200s. Again, I'll be talking about GPUs a lot today because I would like to really, for this meeting, to have a focus on AI and capabilities and what cloud providers support. And we run around 10 petabytes of storage, so it might seem very small for you all. 2,200 users. We basically support 550 faculty labs. We have 1,300 faculty at Notre Dame, so it's kind of, nice percentage of faculty are using us. But not all of them would be like, there is a long tail of science here as well. And then we started supporting more classes than ever, and especially through Google Colab, we see more and more interest from faculty of using, modern AI tools, and it appears actually that providing Google Colab is much more cost effective than it is through buying a small system and provide it to the class. So it's a very nice use of Colab. Now, I'm not paid by any of the cloud providers, so the full disclosure, but this is the reality, right? We're going to be talking about these cloud providers, and then in my group, I have 50 faculty and staff, and only 13 out of that us support the HPC systems and also provide the support to our users in terms of how to run jobs, configure their scripts, etc., etc. Now, this is also maybe very, very important. Notre Dame would provide funding to support around 30% of all the systems that we run. So 30% is really centrally funded, and the rest is coming through grants, but also through faculty startup packages. And then we utilize this beautiful co-location data center at Old Union Station here in South Bend. You'll see exterior and interior. Behind this building here on the top, you see the old Studebaker factory that looks much better now, actually. This photo is from 2012, I think, but it's a fully renovated space now. It's like a technology hub in South Bend, and really kudos to the owner who purchased it from the city and renovated it for a new beautiful space. But yes, here's our data center, and we are probably the largest tenant in this data center. So the cloud question, why even bother about the cloud, right? And we run on-premise, mid-size, kind of small to mid-size on-premise infrastructure. And, we really, there are several reasons why we think about the cloud and why we kind of started actually recently building our cloud strategy. Because we never had one, and we always were like looking at the cost, it's too expensive for us as a unit that provides central computing, right? But even to faculty who, run the jobs all the time, we always kind of look at this like, 24/7 utilization, right, aspect of it. But many faculty, in fact, don't have to use it 24/7, right? Then we have to also provide compliant infrastructure. So we really have to deliver HIPAA, COI, PHI infrastructure for various projects, including health data and so on, but also DoD and so on. So cloud was always an option for us here, and we actually utilize AWS for HIPAA, PHI. We run CUI on premise. But also right now we are kind of considering, okay, we are getting more and more hospital patient data from hospitals, also insurance data. And the question is, okay, how are we going to analyze this data in the cloud? Do we run all the model training in the cloud, or we rather move this data back to the CRC and do the model training there, right? So it's a very kind of business-driven, but also compliance-driven question. And we might actually want to change the way we manage the PHI and HIPAA data in the cloud. We shall see. And then of course we have spikes, right? So we have more and more faculty are becoming like want to really run a larger infrastructure that is not available in our data center. We of course help our faculty with going to NAIR and going to other national, infrastructure like Access and also DoD lab supercomputing centers. But again, some of faculty are trying the cloud. We actually run now a scientific AI initiative where we have cohorts of PhD students who are fellows of this program, and they also have different interests, various interests in kind of different architectures that we don't have available in our data center. Yes, also what happened is that our landlord, because we are in a co-location situation, right? Our landlord decided to sell the data center, and we've known the guy for 18 years, and suddenly we have a new landlord who we don't know how's going to invest in this data center. It appears actually that the current new landlord is more interested in carrier services, so really networking, and might not want to invest in the data center as much as we want, right? So there is another question, and the other one is, okay, do we want to purchase like hundreds of GPUs, H200s, H100s, or others to our research center, not really understanding fully if they can be, if our community is ready, right? So do we want to invest a lot of money and spend on GPUs, and at the same time, we might not see the use to the level that we want, right? So training is a huge component here, and not only our faculty and students, but then also undergrad students, and I'm talking a bit about this here also. Our students are I would say a very, very important element of this decision, right? We really want them to be able to get good jobs when they graduate, and we believe that really providing them access to various clouds for workforce development purposes is very important. Then, of course, certain workloads are better suited for cloud, and some are less. So this is another reason why we look into the cloud. We have a software development team that develops, portals and data sharing platforms, web-based analytics, and where cloud services really provide better scalability and global access out of the box for this kind of purposes. And then, of course, it's also about strategic positioning, right? We want to ensure that CRC remains flexible and sustainable long-term by leveraging both on-prem and cloud rather than really risking stagnation and waking up one day with just a single approach and so on. So these are kind of very important questions to ourselves. And I think every organization is different. So everyone's decisions are driven by different both organizational and strategic aspects. So yes, we know there are like basically 5, 6, 7 maybe, but top 4, 5 major cloud providers, and we've done several reports. You can look for more information in these reports. You can go to the websites and check what they do. But today again, I will be focusing more on AI platforms that these providers deliver and what kind of both hardware and software is available through them. So AWS, as you know, is the oldest and I think most widely adopted platform, and they have probably the largest share of the market overall, but also including academia. Azure, they launched AWS came up in 2006. Azure, I think, is 2008, so not a few years later only. And they gain traction, especially among institutions already using Microsoft software. They kind of emphasize integration with on-premise systems and offer from the very beginning the broadest regional coverage and marketing for globally distributed collaborations. And I think this was their strength from the very beginning. Then Google Cloud Platform, GCP, is really known for its strength in data analytics and machine learning. So like you remember Google BigQuery, TensorFlow, these are all the products from Google that are made available also through their GCP platform. And their market is maybe smaller, but also appeals very much to data-driven and open source-oriented research groups. And I think very, very much worth looking at. And then Oracle, which is kind of, I would say, new kid on the block, Oracle Cloud Infrastructure, they really leverage Oracle's enterprise experience. OCI, Oracle Cloud Infrastructure, has been really differentiated with high performance offerings. So really, they really provide probably the most performant systems for HPC workloads, but also GPU systems, and they're specialized actually in bare metal provisioning. So especially for GPUs, but also HPC environments. And I've been talking a lot to all of these providers, and maybe number one thing, because of course we want to understand what they can provide and how they can support our mission, but then also to make sure that we always know how they compete, what is the competitive platforms, and very often we would be using different platforms for different reasons. So we are not like buying into one of these platforms, right? And I think this is also a possibility for all of us. So let me give a short overview of AWS. So they really provide the broadest portfolio of cloud services and a global infrastructure footprint. Researchers can find virtually any resource that they need. So really from standard servers like specialized databases within their offerings, HPC, they have compute optimized EC2 instances for HPC specific workloads. They have also very fast, low latency interconnect between instances called Elastic Fabric Adapter. And then, on the AI ML side, they really not only offer the latest NVIDIA GPUs on demand, but also they have their own proprietary chips like Trainium and Inferentia. And as you know, AWS have many programs, especially the current program that they have an open call for is looking for researchers willing to, use Trainium for their research in various domains of science and engineering. They engage with the community very, very strongly through various programs. As you know, they also started several AWS hubs across the country, like Virginia Tech and others. And actually what they're doing right now, and they become very interesting to us, they're building one of their largest data centers just across town from Notre Dame. I can tell you we run a small data center, so that the systems that we run at the Union Station, they consume around 1 megawatt energy. So it's really small. The data center that AWS is building is going to equip them with mostly NVIDIA and the Trainium chips will be 10,000 times bigger. So, imagine 5.6 gigawatt of energy being drawn to these systems. It's huge. It's actually impossible right now for both Michigan and Indiana to deliver enough power to these data centers. So they're going to do it for sure in many phases and in many years. But with this, they also trying to work more closely with Notre Dame, and we hope that this will be a long-lasting collaboration. Yes, the machine learning platforms that they provide, the flagship Amazon SageMaker, which is a fully managed service to develop, train, and deploy models, and deep learning also containers that come preloaded with TensorFlow, PyTorch. So really fully equipped environment that researchers and developers can use to deliver their AI platform. Please interrupt anytime, okay? But again, this is mostly just an overview of different providers. Then Microsoft Azure is always the top choice for organizations that already invested in Microsoft ecosystem. They're also very strong in compliant infrastructure, but so is AWS. But I think many DoD projects are using the Microsoft Azure. They boast the most extensive regional presence. They have around 60 regions globally. As you know, they collaborate and they invested in OpenAI. So they run one of the biggest OpenAI service worldwide. Although OpenAI also has signed, as you know, contracts with other cloud providers or data center providers. So actually, Microsoft is withdrawing from some contracts when it comes to data centers. But they really provide specialized virtual machines with also very fast InfiniBand connectivity to support MPI workloads. So really very strong computers for HPC. And then also they provide VMs with NVIDIA GPUs such as 8100s and InfiniBand for distributed deep learning. So really very nice infrastructure for AI workloads. And of course, there are other aspects to look into, but pretty good. They have also pretty strong hybrid cloud story with its Azure Stack platform. Basically allows an ecosystem cloud environment on premises, and Azure can project on-prem or even other cloud resources into Azure management platform plane. So on the software side, I think I need to mention Azure ML machine learning, which is the Microsoft end-to-end platform for developing and deploying ML models. And here, also pretty interesting, they have support for and integrate popular frameworks like PyTorch and TensorFlow, and offer ONNX for model portability. And as I said before, they provide Azure OpenAI service, which is giving access to GPT-4s and other language models in a controlled environment. GCP, Google platform, it really tends to attract researchers who need powerful data processing and machine learning capabilities. Their Google AI's platform is Vertex AI, which is a unified Google's cloud machine learning offering. and allows researchers to do everything from data labeling to training to deployment in one place. Again, you can do your models training from end to end and deploy them for use. What is distinctive, I think, in this offering is their TPU tensor processor unit, which is Google's development. It's a custom developed AI accelerator available on GCP for anyone, basically, doing large-scale neural network training. TPU version 4 pods have up to thousands of TPU chips interconnected by an ultra-fast network. So it's kind of like a turnkey AI supercomputer for deep learning. They also have, of course, NVIDIA GPU instances like 800s and H100s and now H200s, similar to other clouds, so very, very comparable. But their TPUs can be a game changer for certain workloads with their mix of high flops and memory bandwidth. So really worth looking at. Then GCP's emphasis is really on containers and Kubernetes, like Google Kubernetes Engine. And it makes it a great platform if you want to develop portable cloud agnostic workflows. So if you really want to, avoid lock-in, this is the way to go, right? And then, well, all these platforms, AWS, Azure, and Google, they provide credits to researchers. Google actually has recently been very, very aggressive in kind of looking for good use cases and giving large allocations to researchers. I've seen such ones like $100K in dollars to $200,000 and probably even more. They were also very good in supporting startups, I must say. Yes, we also talk to them a lot. Of course, they're a major provider for our mail and workspace or collaborative environments over Google Drive and so on. Then Oracle is kind of, I would say, pretty interesting, and they came late to the game. They, I think, started in 2016, and they provide, so-called cloud or cloud infrastructure. I like Oracle because many of the people I talk to there, they come from Sun Microsystems background. So really, if you remember Sun Microsystems, they're very academic oriented and driven and built and they really understand academia. So this is what I noticed. They really understand academia and every second person I talk to at Oracle is a former Sun Microsystems. They are focusing on performance, high performance workloads, and also bare metal performance and cost efficiency. And I really strongly recommend talking to them. If you haven't yet talked to them and considering cloud, I think their cost model is very aggressive. Of course, each of us has to make their own comparisons, but I haven't seen the pricing that they offer for this 8 times 8 GPU, NVIDIA GPU for actually H200s. It was very, very good price offering. Still, of course, more expensive than we would run on premise, but I would say worth considering. And again, depending on the use case, right? They also have the interconnect RDMA, remote direct memory access clustering. So they have 100 gigabits per second RDMA links that allow GPU clusters to scale similarly to on-prem HPC clusters, which is also worth noting here. And they have data science service. This is also kind of manage Jupyter Lab environment and support typical machine learning workloads. So again, I saw price gains up to 30, even 50%, and this is what they say online. But I've checked, this is true, and really, but on the other hand, Oracle's cloud user community in academia is really smaller, much smaller than AWS or Google or Azure, and I think it would be very, very hard to find partners who did work with Oracle and can share some experience. But I think talking to other universities or research centers is very important. So basically, these cloud providers provide really good coverage for both AI and HPC. In terms of raw compute and network, I think Azure is stands out really with 200 gigabits per second InfiniBand. I think AWS Elastic Fabric Adapter provides custom 100 gigabits and also is very suitable for many MPI codes. The RDMA that I mentioned from Oracle, very low latency and very, very good solution for the interconnect. From the accelerator perspective, I would say all providers give on-demand access to NVIDIA's novel, newest hardware, like from V, ACE, and H systems. So really very comparable. Both Oracle and Azure actually provide bare metal GPU servers for maximum performance. The difference there is, though, that Oracle doesn't provide GPUs in a pay-as-you-go model. So you really have to book the system or pay the system for 3 years minimum, I think. So again, maybe this is negotiable, but worth remembering that you cannot just pay as you go with Oracle. They really are willing to build a system for you and your sole use for a minimum 3 years. So maybe this is important. The AWS Power Cluster and Azure Cycle Cloud are tools that can spin up a temporary HPC cluster. So these are also very good solutions for you to spin up, quickly an HPC cluster. Then storage side of things, when you compare this all, you need, for HPC workloads, of course, fast IO. And then AWS here offers FX for Lustre. Azure has HPC Cache and NetApp, so they use NetApp files for high-speed storage. Oracle's uses BGFS and Lustre as well. For when it comes to AI platform space, I would say all cloud platform provide managed services for machine learning development. And again, very comparable but different, of course. But they all can simply satisfy running ML workflows at scale. So again, I think worth looking at them all. But really, in summary, no single provider has a monopoly on HPC or AI capability. Researchers can find powerful options on each of these options or with each of the vendors. And also look at stuff that might be improving your performance, like TPUs or on Google or ultra dense GPU availability on Azure. And I would like to talk a bit about this other offering, and actually this is also our experience. We had to look at maybe if we don't want to build our data center, maybe we can look at other options. Actually, for some of these options, you need your data center, and they allow you to deploy the cloud infrastructure in your data center. So I'll talk about AWS Outpost, which is AWS in your data center. I will talk about Azure Stack, which is the services, Azure services on premises, then Oracle Cloud and Customer, and Google Distributed Cloud, or private. I think they call it private region. So the Outpost extends AWS infrastructure in your own data center. Essentially, what happens is AWS would ship you a rack or bigger, units, or smaller. It's I think minimum is like 2U Outpost servers that you can deploy in your data centers, and they're like filled with AWS hardware. They remotely manage it, so basically management is on the AWS side. and you can use it to run AWS services on-prem. This may appeal to kind of use cases where you really have low latency or local data control. Some use cases might be very interesting for major facilities as well. So suppose you have, for example, an experiment generating a huge data stream. So you can deploy this EC2 cluster on outposts to process it on site in real time, but still, have that tied into AWS, either S3 or other data solutions. Outposts can also support many core AWS services like EC2s, EBS, S3, RDS, and they're working on more to be added. The outposts are usually connected also to AWS region, from the developer's view, using outposts feels like using real AWS. The same API, the same console. You really only choose the availability zone that corresponds to your outpost. So it really is very good for kind of hybrid consistency and so on. I think worth looking at if you want to think about low latency kind of approaches. For Azure, they have similar solution called Azure Stack. This is basically delivering Azure services outside Azure's public cloud. Their primary offering here is Azure Stack Hub. Stack Hub is a kind of turnkey solution delivered usually by Dell or HPE that installs in your data center and provides a suite for Azure services on premise. The developer admin experience here is consistent with Azure, so you use the Azure portal or a command line interface, pointing at the Azure stack and endpoint, and so this is the only difference instead of pointing to the public cloud. Microsoft has also the Azure Stack HCI, which is more like a hybrid cluster solution to run virtualized workloads. And then Azure Arc is their management layer that lets you treat on-prem or even other cloud resources as part of Azure. So again, yes, very interesting. They can deploy this Stack Hub for local processing, and then here we go. Oracle's is a dedicated regional cloud customer. Right now, you can basically order at minimum, I think it's 3 racks of gear of servers that will be deployed in your data center, and again, it's going to be managed by Oracle. They actually do it for all the Oracle Cloud services. So you can deploy all the Oracle services on your own racks in your data center. But again, Oracle will manage this region similarly to their public regions, actually. The selling point here for organizations with stringent data and latency needs. So really, again, if you have some data sovereignty and latency requirements, this is the way to go. Like if you want to compare it to Outposts and Azure, very very similar. But also when it comes to hybrid solution, they're pretty complex and depending on what also systems you're running in, like queuing systems in your data center. And then Google Distributed Cloud, the GDC, is Google's hybrid and edge solution. They kind of consist of 2 different offerings or parts: GDC hosted and GDC edge. Distributed Cloud hosted is essentially a self-contained Google cloud that can run without any internet connection to Google's data centers. So imagine, you have some of line analysis, let's say on a vessel, right? You deploy a little GDC edge, and so you can really run analysis offline and then move it to the cloud when you connect to the network. You can also use very easily like small 5G base stations on a small connectivity and provide some edge computing on your remote vessels or platforms. Under the hood, both offerings tie into the Anthos, which is the platform for running Kubernetes. So Kubernetes is available also for this solution. And then I wanted to talk a bit about LLMs in the cloud. In the CRC, we build agentic workflows, and we provide, basically endpoints to major LLMs to our researchers, our software engineers, knowledge engineers. Here is an example of how we deliver agentic workflows for data lifecycle processing. And we really build this kind of with very minimal human in the loop, agents that allow us to control the data flow and processing data from data sources to knowledge. And for this, LLMs might be very, very helpful. So I went ahead and kind of looked at a comparison of what different cloud providers do here in this respect. So of course, I don't want you to read all this, but I will make the slides available. But I want to say that cloud providers have different approaches here, but also overlap a little bit. AWS emphasizes breadth of model choice and integration with their existing AWS tools. So their offering is really integrated, and Amazon Bedrock provides one-stop API to many models like Claude, like non-AWS models as well, and so on. They lack native OpenAI GPT-4, but offer alternatives like Anthropic, AI 2.1, and so on. They also have strong support for open source framework like Hugging Face integration, and then of course pricing can be high for on-demand GPUs. Again, you can use here AWS's academic credit programs and partner with open data on AWS, etc. So really there's way for researchers to start. When it comes to Azure, they leverage its partnership with OpenAI to offer cutting-edge models like GPT-4s and others. This is a big draw for researchers needing the latest GPT series capabilities without managing any infrastructure. And this infrastructure, of course, can be pricey as well. Azure also has Llama 2, Mistral, and other models. So really, they really show a hybrid approach, and one can compare these OpenAI models with open models under the platform, under one platform. And this is a similar way how we do it in the CRC. We offer our researchers many different models through kind of endpoints. Also, Azure has a tight integration with Hugging Face Hub, and tools like MLflow and pipelines can accelerate experimentation. So really interesting environment to work with. When it comes to Google Cloud, they're focused on innovative Google developed models. So Gemini, PaLM 2 are really two models that are designed for high performance and complex tasks and multimodality. We use also Project Astra that you can integrate with Gemini for more like multimodal conversational kind of interactions. Vertex AI also embraces open models like Llama 2, and really also they prove to be very flexible. And then Oracle, Oracle does all this, but also their interface is kind of crude. I would say they need to work on their interface. It's all mostly Java, and I think it kind of looks old-fashioned. But again, they kind of carve a niche in high performance and open source centric AI. They have access to powerful elements without kind of licensing worries. And then Oracle also free tier is kind of, I hear that the free tier of services and systems is really underutilized. So they're willing to offer significant credits to attract users, and I think it's a really also a good time to talk to them. And again, we'll talk about the future of our working group, but I think it would be nice to hear from these vendors directly. Now, a few words about negotiating, and I think don't take the pricing from the website, or also calculator is not everything. I think it is very important to really understand the ecosystem, really get quotes from everyone, understand what discounts are reasonable, and how much we can ask, for the bottom line, right? To be smaller. Large customers, of course, rarely pay the sticker price, and I think most of you are really large customers here with the science that you're doing. What else? I think data egress, and again, all this you can read about in the report that is available on Zenodo. But both moving data off cloud can be notorious budget killer for data heavy projects. So make sure you're doing the right thing here, and it's wise to address egress costs in these negotiations. When it comes to asking for a price, really don't be afraid to RFP. I think this is still a good process, and I think asking for pricing, but also trial periods, and also user support, right? Like we have to really skill up our teams to be able to work in the cloud when we are used to on-premise. So training and user support is very important. I think we can really get good deals with cloud providers on this. Also, we have Bob Flynn is here from Internet too. They have nice agreements, and Bob is always happy to help with talking to cloud providers and get a good pricing. Then what else? Negotiation is really important part of your plan, and I think it should be in your plan. It's not only about the cost. Again, I think it is important to think how contract terms can support your mission, and I think it's important to engage in really continuous negotiation, because the prices change, right? And I think it is important to always reevaluate your strategy and your current engagement. I think this is not a one-time negotiation. Probably this is what I want to say. Also, timing is important, but I think it is really crucial to retain control of your data. And major providers say that your data is your data, but make sure that your contract also explicitly states that. Clarify how you can retrieve your data and in what formats, and then determine and agree on how the data will be deleted on their end when you need it. This is more about really the governance than price, but it's really a key part of the negotiations for research. You should also ask for value adds, like for instance, can they provide training for your researchers and stuff? And I mentioned this already. They have cloud credits, ask for them, and then be ready to walk away, or at least create a pause in your negotiations. I think I think there are many options out there, and take your time. So really make sure that you have enough time for negotiations, because you may come to deadlock and want to talk to a different vendor or so. So really, sometimes it's important to kind of walk away and at least create a pause on these negotiations. Finally, get everything in writing, because people, leave, they lose their jobs sometimes. And I think, don't rely on verbal promises from your vendors. This will protect you and sets your clear expectations between you and your vendor. So also, what is important to remember, we have also NSF-funded academic cloud initiatives, right? And I think they're kind of maybe forgotten a bit. And when we think cloud, we don't think about these infrastructures, but they're very valid and good infrastructures for us to use. So Jetstream is the NSF-funded community cloud resource managed by IU, Indiana University. And Jetstream 2 offers, as far as I know, 8 petaflop of capacity, but it's kind of spread across multiple data centers. It is essentially an OpenStack-based cloud providing on-demand VM storage and also Kubernetes. It's also available through access allocation systems, and look at this if you're interested in using some more science-based clouds. Then Path, which is another solution here and offering, it's a collaboration between the University of Wisconsin and OSG. As you know, OSG is like a massive distributed cluster that spans universities and labs worldwide. We run a kind of OSG node at Notre Dame, and for us, like flow-to-flow jobs from our infrastructure to OSG is pretty straightforward. It is optimized for high throughput computing, and so you think about very many individual jobs that manage hundreds of thousands of data files to process independently. And many projects like LIGO, particle physics, and so on use OSG already. So OSG and Path is a way to extend your capacity without buying new hardware. So really, if you run an OSG infrastructure in your data center, then you have access to all OSG and via Path. And this is really free in the sense that resources are contributed by the community and centrally scheduled. You just need to have your software packaged and run this on heterogeneous sites. Path also coordinates using commercial clouds, and when we need it, they can connect you to commercial clouds, and you can easily run on AWS or Google using your NSF cloud credits. And I think again, this is very possible. So really, I think it is worth including Path and OSG in your strategy. You will be ensuring you're using all freely available capacity at the academic ecosystem, and this is a lot of resources that you can tap into. And then CloudBank, which is trying to simplify cloud access, is also an NSF resource co-managed by UC San Diego, University of Washington, and UC Berkeley. It's kind of new, but not that new. They actually just expanded it to CloudBank 2.0, and they added IBM Cloud and also Oracle, NVIDIA specialized cloud offerings. But yes, they are kind of like a broker between you and cloud providers. They take care of billing and compliance, and also provide training. So, it doesn't mean that you don't have to worry about setting up cloud contracts, etc. But you have to work with your university also or institution to Sorry, so they would run this for you rather than through your institution. Right now, we do through our institutions. Yes, they have some stuff that can provide user support. So again, something worth looking at, and I know we already talked to you all about this in extent. Cloud strategy. I think there are a few goals to remember when you want to really build your cloud strategy, and I think good starting point is the inventory of your needs and assets. I think identifying what workloads might benefit from the cloud is important, and so on. Of course, you want to run some pilot projects and pick some small, manageable, moving portions of your data analysis to the cloud. At the same time, you need to skill up your team, so really think about training. Put governance also in place early, and I think about how you're going to govern cloud resources and so on. And it's an iterative process. You don't do it only once. You have to revisit your strategy, and you really do it basically at least once a year, I would say. So the future outlook, I think, really the line between cloud and traditional research infrastructure will continue to blur. I think this is why it is very important to think about, your own cloud strategy. Also, cloud providers are advancing the state of the art. For example, like Microsoft Azure, so like an OpenAI, this is a good example. But I think it's becoming also very similar to on-premise HPC centers. Many are deploying open on-demand portals. So you have like, web GUI for submitting jobs, similar to Cloud Console. Also, schedulers like Swarm are adding plugins to Burst to cloud as well. And then we also foresee more federated computing ecosystems. We're going to see, open science grids and XD-mod APIs bridging different resources types and cloud, and then tap also to an NSF supercomputer. So yes, I think conclusion, really cloud capabilities for AI and HPC especially have matured to the point they can significantly accelerate scientific discovery. And I think, for research institutions and NSF facilities, developing a cloud strategy is no longer just an option, right? I think it's becoming an essential complement to on-prem resources. And I think a balanced approach is recommended. Keep on-prem clusters for steady, predictable workloads and data locality, but also start leveraging cloud for elasticity and peak demands. I think well-crafted cloud strategy involving technical integration, hybrid cloud, financial planning, and training researchers to use cloud tools can empower even small institutions to compete in big science. And I think really worth thinking about it. I think even for on-premise organizations like MyCRC, investing time and effort into cloud is an investment in future-proofing research and innovation. So thank you very much. And yes, I went for an hour. I thought we have another 30 minutes for those who have time. But really, I wanted to ask whether you had any questions and, how these trends that we talked about affect your institution's cloud strategy. Are there any particular challenges maybe that you're facing around cost management, data security, or others? And then also wanted to talk maybe a bit about Cloud Working Group, and its future, what directions we should take. And I think, let's open the floor and your insights will help actually to define the direction for the community. Thank you so much.